Good afternoon, all, and again welcome to this lecture of memories, where we were studying semester two and paper two of BSc second semester RTM Nagpur University in Nagpur BSc Electronics, right? And myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science, Nagpur, and I guess my screen is visible over here. Yeah, right. So my screen is visible to you. Right. So yeah, myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science, and today we are going to learn about the dynamic RAM and the static RAM. Okay, so let us start with this. What is RAM actually? What is memory? Okay, and according to that only we are going to understand why we are using these memories and what is the necessity of this memories. So let us begin with the basic architecture of say the motherboard, right? So which is in the inside the PC, personal computer. Now, if you are able to see over here, we are having a CPU, or and then we are having some. Oh, sorry. Yeah, then we are having some buses, right? So and these are the memory slots where we are supposed to put the RAM over here. RAM, random access memory, and these are the bus, a pathway or a set of pathways, lines of wires from where we are expected the data to be transferred from the CPU to all the other portions of the computer, right? So that is called as the bus. Bus is nothing but 8 parallel lines or 16 parallel lines depending on the data on which we need to process, and it is being connected to the CPU accordingly, right? So this is the memory slot that we are having over here. This is IDE slots. These are all slots over there, and these are USB, SATA, and this is say I23. That slot over there, printer port, and these are the buses. So as you are able to see, these yellow lines are supposed to be the bus. Bus means where we are going to have data to be transferred from this portion to the CPU. Right now, we are basically concerned with this portion, that is the memory. Now, these bus are very important because they are the ones who are going to send the data. Now, this 66 megahertz bus means that the data is going to be sent at the rate of 66 million cycles per second. Just imagine this is the speed that we are expecting. The higher the bus speed, the faster the computer, right? So the speed of the bus determines the speed of the computer, right? So in when we expect that the computer to be fast, we take the bus the highest speed of the buses, right? So here we are expecting that it is traveling at the speed of say 66 megahertz per second. That is 66 million cycles per second. And the last one that we are having in this is these are the memory chips, and something I guess I'm missing. Uh, yeah, so these are the connections between the CPU and the chipset, that is the NOT bridge over there. So this is the actual diagram of the motherboard that we are having. Okay, now let us start. So these are the memories where we need to set. Now, what are the types of memories? So the types of memories are read-only memory. Refers to memory in digital system that has only read capability, can be used to perform logic operations. Right now, what is this read-only memory? Is nothing but where we are going to store the data and we are only able to read that data, like our CDs, right? So compact disc, where they are not rewritable CDs, right? So we are expecting that CDs where we have written the data once, we are not able to rewrite it. Okay, so that particular sort of memory is called as read-only memory, ROM. Read-only memory means where we are not going to write anything inside it after this. So once it is written, the data cannot be changed. That is why it is called as read-only memory. And one more thing, that even if the power is switched off, the data remains intact in there, right? So that is the read-only memory. Then we are having the random access memory. Now we are going to study this RAM, random access memory, that is RAM. Now this RAM is nothing but a semiconductor sort of memory where we are going to put the data temporarily, and It is actually a non-volatile memory, which implies that as soon as the power is switched off, the data which is inside it is being lost, right? So to retain the data, we expect that it should be continuously powered, right? So that is the random access memory, and it is actually supposed to be the mostly it's high speed temporary storage memory. So it is having the highest speed capable, where we are able to read as well as where we are able to write. Read means from where we are going to read the data, and write means where we are expecting the data to be written inside it. That sort of memory is called as RAM, random access memory. So the memory can be accessed. I will let you know this. And these are having two types, which we are going to study today. The static RAM, we call it as SRAM, which is able to store its information as long as power is applied, and it does not lose the data during a read cycle. Early memory was mostly SRAM. So early, where we are initially when we are started with this memories, there were only static RAM sort of memories. Okay, now the question over here is the we'll study this in depth, that it is having the data. Now again, as soon as the power is switched off, the data is lost over there, right? So but it is having a highest speed. Okay, so it is not losing the data during the read cycle. Now this is important because this is the basic difference between the DRAM and the SRAM, right? So it does not lose the data even if we are reading the data from the static RAM, right? The second one is the dynamic RAM, that is DRAM, which uses a capacitor to temporarily store the data, which must be refreshed periodically to prevent information loss. And the data is lost in the most DRAMs during the read cycle, right? So DRAM, that is the dynamic RAM, right? It is called as a dynamic RAM because it has to be refreshed. The capacitors having the property to leak the voltage, and therefore it has to be refreshed continuously, and that is why it is called as a dynamic RAM. Now it is going to use the capacitor. We are going to study this circuit and the concept of DRAM in depth in the next slides. This uses a capacitor. Now, this capacitor is going to store the charge in the form of data, whether it is 0 or 1, right? And due to that, there is a property of the capacitor to lose the data through leakage current, right? So to save the data, refresh the data, we need it to be given continuously with that powers, right? And some of the data is being lost during the read cycle. So when we read the data from DRAM, the data is supposed to be lost, right? So it has to be refreshed again. Now SRAM takes the approximately 4 times the silicon area of DRAM with the same technology. You'll see that we are using 6 T cells, means 6 transistors in one SRAM, whereas we are using only one transistor in DRAM. So I'll show you in that construction part of the section where we are going to show you the circuits, right? So the circuit of SRAM is having 6 transistors, right? Which it is employing in that, but as compared to DRAM consists of only one transistor. So depending on that only, the area which is required by SRAM is should be more, that is 4 times the silicon, 4 times the area required by the DRAM with the same technology. This technology is same types of transistors we are going to use. Now, the digital system also includes usually high-speed, small-size memory registers to temporarily store information used in operation. So we have studied these registers. They are nothing but the flip-flops. The memory chip usually includes the storage cells, address decoders, logical circuits for selecting and accessing a particular cell, and sense amplifiers for amplifying the signals retrieved retrieved from a cell. Okay, so these memory cells where we need to store the data. Now, you just remember the data that is to be shown is to be stored in zeros and ones. So they are storing it in the form of bits, right? So they need it to be stored in a digital format, zeros or one, high or low. So the memory chip usually includes the storage cells that are address decoders, logical circuits, and this is what the memory in all requires, when we say a memory, it requires the storage cell, we require address decoder, we require a sense amplifier, which is very important because while reading, we require an amplifier to compare the inputs and output data, right? So that time we require this sense amplifier. So this shows you how much devices it requires for one cell. So it requires a storage cell, address decoder, then the logical circuit and accessing a particular cell, that is sense amplifier, for amplifying the signal that is being retrieved from the cell, right? So these are the types. Now let us start with this, the memory, SRAM and dynamic RAM. So if you compare both of them, SRAM and DRAM, it appears that the SRAM is more faster as far as speed is concerned as compared to the DRAM. DRAM is a little bit slower. As I told you, we are employing capacitors over there in DRAM. Therefore, it requires the data to be stored. So it is a little bit slower. As I again told you that when we read the data from SRAM or DRAM, in SRAM, the data is not deleted, it retains the data, whereas in DRAM, there is a possibility that it can lost the data, right? So it has to be refreshed as soon as we are reading the data. Now, as far as size are concerned, these are having a very small size and these are large, then expensive and cheap. DRAM are cheap, used in cache memory, whereas DRAM are used in main memory. Then density is having a less dense at respect to highly dense because the capacitor which we are employing over there requires a larger space. Then construction complex and uses transistor and latches. SRAM has a complex construction. I will show you that. And this is the simplest of the construction that we are employing only one transistor with a capacitor. That's all, right? And single block of memory requires six transistors. I told you six transistors, six T cells. So we are employing six transistors in SRAM, whereas in DRAM we are going to have only one T cell, only one transistor. Then power consumption, SRAM is having a low power consumption as compared to say the DRAM, which is requiring high power consumption. So this is basic comparison between SRAM and DRAM in all. So we require this. Sometimes the questions asked in the university difference between SRAM and DRAM. So this is very important. Okay, so these are the differences, characteristics of that. Now we'll start with dynamic RAM. Today I expect that we might complete this portion, that is dynamic RAM. Dynamic RAM consists of, say, these are some of the characteristics of dynamic RAM. Now this dynamic RAM stores the data as charge in the capacitor. So the data is being stored in the form of charge, high or low, right? So the data or the bits are being stored as a charge which is in the capacitor. Then the charges which are being stored in the form of in the capacitor in the form of charges, they have the characteristics to leak the current, and therefore it has to be refreshed. That's what we are talking, and it requires refreshing even when powered, right? So we have to continuously give on the power for refreshing or recharging of the capacitor, as it has a tendency to lose the data through leakage. Now it has the simplest construction. I will show you, and smaller per bit. So for a bit to be stored, it is comparatively smaller as compared to the SRAM. Then it is less expensive. It needs a refresh circuit, and that is more important. It requires another circuit to refresh the capacitor, right, in the equal interval of time. So it has a slower as compared to SRAM. Then it is a main memory, and it has essentially analog. That is, since the capacitor charges and discharges, say exponentially, capacitor discharges exponentially. Therefore, this is actually, it has to be the analog system. So the charges which are being stored in the capacitor are essentially analog, since we are expecting the digital output. Now let us see the dynamic operation of the SRAM. I guess I have, yeah. So this is the basic structure of the DRAM, where we said that we are having only one transistor. As you are able to see, this is a transistor, and actually it is a MOSFET. We are having a sorry, we are having a MOSFET over here, which is actually the depletion type of a MOSFET, and here the base or uh, the transistor has say the gate is connected to the address line, the source is connected to the storage capacitor through ground, and the bit where we are expecting to read or write the data are being connected to the gate, right, like this. So we are having one transistor over here, and which is connected to the base. So as soon as base sorry gate, so as soon as the gate terminal becomes high, so automatically the current starts flowing through this, and this becomes on, right? So this is how the address line active when a bit read or written. So this address line should be active, and transistor switch is closed. That is current flows. So how we are able to write the data? So whenever we need to write the data, voltage to the bit line. So this bit line should be high or low, right? Depending on what we need to write it in the cell. So this is actually a 1-bit DRAM cell. Okay, dynamic memory cell. And here we are using this capacitor, which is being charged or discharged accordingly as per data is to be stored. So let us see high or high. If we give high or low, then what happens? Then signal address line transfers the charge to the capacitor, right? So as soon as this address line or this bit line becomes on, then that this bit which is high or low, either high or low, is being transferred through this capacitor. If we want one over there, then this should become high. As soon as it becomes high, the charges are stored in the gate and in the capacitor, and the capacitor gets charged, which implies that it is one. Okay, when it is low, then the capacitor discharge through it, and the bit line becomes zero. So signal, that is the signal address lines. This address line is playing a very important role in that, in writing the data. Similarly, for red, it we have again this address line should be selected, which address line is selected, and accordingly that particular bit cell is being selected. So address line is selected, transistor becomes on, and as soon as the transistor becomes on, the charge from the capacitor fed via bit line to sense amplifier. Now here we need to connect a sense amplifier at this portion. This is again nothing but the op-amp circuit. I guess you won't understand what is op-amp. Op-amp we are studying in it in the next semester in very depth, right? So it is actually an amplifier. So whatever data is given to that amplifier, it is being amplified so that we will have a high or we have a low, right? Accordingly. So this charges from the capacitor fed via bit line to a sense amplifier. So here we are going to employ the sense amplifier. Let us see, we are having that slide. So which compares with reference value to determine zero or one. So this is actually nothing but a comparator amplifier. So it is going to compare from zero or one whether the output is high or low. So this is how dynamic RAM works. And say the capacitor charge must be restored. So this is how we are having. So if you say that this is a transistor and this is a capacitor, so if we need to store the data, they should be recharged. So if it is zero, then it's okay. But if it is one, then these charges are to be refreshed, and at every equal interval of time, we are expecting it to be refreshed by giving the data, giving the power to it, right? So this is the better animation that I need to show you, and this is a transistor through which it is going to charge if it is one, and also it is going to be zero through this transistor only. So we are employing only one transistor over here and a capacitor. So the construction, as you are able to see over here, is very simple as compared to the static RAM. But the drawback of this dynamic RAM is this is the structure of that dynamic RAM, and the basic drawback of this dynamic RAM that is to the capacitor is to be recharged or refreshed in equal interval of time, as it is having the property to lose through leakage current. So leakage, to stop that leakage, it has to be refreshed. So every time this capacitor has to be charged, so we have to keep charging it, and it requires another circuit which is called as a refreshing circuit, right? So this is the SRAM, which is inside the CPU, I guess, in the motherboard itself, where we are having a slot, where we are having the slots for that RAM, like this, and this DRAM is requiring it has to be refreshed, and this is the drawback of dynamic RAM. Let's start with the static RAM. So I will just start the say the introduction of static RAM today, and we'll be continuing in the tomorrow's class. So, what is static RAM? The characteristics of static RAM are which the bits are stored as an on or off switches, right? So, we are using switches instead of say the capacitor, and there is no charges to leak. There is no refreshing circuit needed to be powered. More complex construction. Now, the construction is complex as compared to DRAM. So, DRAM is only having one transistor and a capacitor in there, and whereas in SRAM we are having six transistors, so that is a little bit complex. We are having a larger per bit, so the rate, uh, so the size, area size of that SRAM is larger per bit as compared to DRAM. Then it is more expensive, as you can see that we are having more larger area, does not need refresh circuit, so we are not reusing this. So that is why it is being faster as compared to DRAM, and it is nothing but a cache memory which is inside the CPU itself. So it has been inbuilt. So the CPU is able to access that cache memory or static RAM initially. Okay, so these are the digital which uses the flip flops, right? So this is the speed that a RAM consists of. So RAM is having say around 100 megahertz speed at which it operates, and if you are having 8-byte wide bus, means 8-bit wide wires, then the speed will be 800 into 100 megahertz into 8 bytes, that is around 800 megabytes, right? And if it is 133 megahertz, the speed at which it is going to operate is 8 into 133, that is 1066 megabits per second. So that much of speed can be expected by using the static RAM. Further, yeah, I guess there were one more that I have missed that. So there are two types of basic electronic storage elements. Those are latch and flip flop, right? So just okay, right. There are two basic electronic storage, that is latch and flip flop. A latch, a memory cell built from two feedback connected networks. Now this is the basic concept of say the static RAM. We are using two feedback connected inverters. I will show you. So we are having NOT gate, uh, रिंग की मिटा दो बताइए. So feedback, uh, two feedback connected networks we are having like this. Rinki Gaur, thank you. So we are having these like this structure. So we are having two inverters. When the inverters means two NOT gate, right? So which are connected like this. So in the feedback circuit, like so, we are having the input V1, then the output of this first inverter is being connected to the input of second inverter, and the output of the second inverter is again connected back to the input of the first. So this is why we call it as two feedback connected inverters, or we call them as a latch, right? So if you look like this, what happens when we apply 0 to V1 over here, it automatically converts it to 1, right, at this point. And if it converts 1 again, then the output of the inverter 2 will be 0, and 0 is connected back to V1. So it remains at 0, and this is how it retains the data, or it latches the data. In fact, we can say that it latches the data. It is used as buffer, right? So these are the second part of the uh, say the static memory. Those are the flip flop. So this is one type, that is a latch, and this is a flip flop which we have studied. This is actually NOR gate RS flip flop. We have studied this. The set reset flip flop, a memory cell built from two feedback connected NOR or NAND gates. So we have used this also. We have studied this also. So in this we are using two NOR gates, or say in that case we might use two NAND gates to construct this RS flip flop. And these are also used as the static memory cells. Okay, so yeah, static memory cells, uh, the set reset flip flop of memory cell but this. These circuits are positive feedback to store information. So this RS flip flop are basically uses positive feedback which stores information in them. Okay, so these circuits have two stable states. We call them as a bistable circuit, on or off, right? Whether it is high or low. So if it is high, then this will become low accordingly. Okay, so these are the latch static memory cell. I need to explain you this. Uh, I guess we will study this in the next session. What is it? So latch static memory over there, and this is how it works, and it's going to show you all. Yeah. So I guess this much is over. One more thing I need to show you. We'll just show you why we require the RAM to be over there. So this is what I have shown you. Or this is the motherboard, and yeah. So RAM is somewhere here, and data is stored in the hard disk somewhere here, right? So this data, the CPU is not directly able to access this data. So in that case, what happens? It requires the data directly. So the CPU cannot get the data from the hard disk, right? So what it does, as soon as you start the PC, first the data is being stored to from the hard drive to this RAM, right? So the data is being stored from this hard drive to RAM, and then the CPU accesses this data which is there in the RAM, and then it continues. So these are the type of RAMs that we are going to employ, and we need to, if you need to increase the speed of say the computer, then we might increase the speed of by increasing the say increasing the size of the RAM. So as you can increase the say increase the size of that memory, then the computer will work very fast. So why? Because the CPU is able to access that RAM directly, whereas this is actually the semiconductor sort of memory, right? And this is the hard drive. So the data is stored in the hard drive. Even if you switch off the power, we call them as ROM. So read only. Sorry. So we have that data over there, and the data can be retrieved from the say hard drive in the RAM first. So even there is no RAM connected in the computer, then the computer won't work. So we require the RAM over here because CPU is going to access the data which is stored in the RAM. Even if it is loose, then the CPU does not work. Okay, so this is the basic concept of say the RAM, and today we have studied say the dynamic RAM. We have seen the chipset board or the motherboard. These are the slots. These are the slots where we are supposed to put the memory or the RAM over there, and these are the yellow colored buses which determine the speed of the computer. Then this is how the CPU works. So the CPU cannot directly access the data from the hard drive. The data has to be stored in the RAM first, and then only it is going to store. It is going to access. The CPU is going to access. Right. So these are some of the memory types that I have told you. Then this is the comparison between the SRAM and DRAM, and the dynamic RAM, we have started with that. Bits are stored in as charge in the capacitor. The charges, those are leaked, so we require the refreshing. It's a simpler construction, smaller per bit. It is less expensive. Need the refresh circuits, and it is lower. It is actually the main memory, and it is a analog as the capacitor charges and discharges in the form of analog. And we are having the DRAM structure like this. So we are having one transistor and a capacitor. This is the bit line, and this is the address line. And when this address line is high or low, this transistor becomes on or off. Accordingly, we can read the data as well as we can write the data also in the same. So these are the DRAM. Then this is how it is to be refreshed. The dynamic RAM, as the capacitor leak the current, leak the current, so it has to be refreshed. Because these animations shows the same. Whereas the static RAM does not require this. So I guess you have understood what we have taught today for static RAM. So we have not yet started the static RAM. We'll continue with this. These are actually the concepts where we are employing the inverter, two inverter feedback circuits or two NOT gates, right? So that they can retain the data. We call them latch also accordingly. So we are going to make this by using MOSFET. So I expect from your side in the next lecture you should study, you should come prepared or just have the idea of what is the MOSFET inverter, MOSFET, or we can call it a CMOSFET, complementary symmetric, right? So CMOSFET. So we are using both P type as well as N type, N channel, P channel or N channel, both MOSFETs over there. Okay, so these are the concepts of the memory cells. I guess we are not going to continue with this today. We'll be having this. So thank you very much for joining. Stay tuned to my YouTube channel. Go through my YouTube channel and watch my videos. Like, subscribe, and share my channel. Thank you very much. I can, yeah. So thank you very much for joining and for your patience listening. Stay home, stay safe, take care. Thank you. Good day. Have a nice day.